let's go to page 608. This is lesson 9.5. This lesson is to apply compositions of transformations. So composition means you're doing more than one. So over here, first let's go over a glide reflection. Okay, it says a translation followed by a reflection can be performed one after the other to produce a glide reflection. A translation can be called a glide. Okay? A glide reflection is a transformation in which every point of P is mapped to a point P double prime. So glide reflection basically means you slide and you reflect. Okay, so that's what glide reflection is. Okay, now, so first you do a translation from here. So translation means you slide the object. So you map the P to P prime. Then a reflection in a line K, okay, that is parallel to the direction. So it's parallel to the it does not have to, okay, but right now they're just doing a glide reflection, so it'd be parallel to the direction of the glide. Okay, so later on we're going to do about what happens if it's not parallel. Okay, but right now the glide reflection means you have to glide and reflect over the parallel line. Okay, okay, so now let's go over example 1. Okay, find the image of a glide reflection. So vertices of a triangle ABC. So here's your ABC. So point A is 3, 2. So 3, 2. Okay, remember this is your X and Y, right? They're in order, right? So it's 3, 2, and then you got 6, 3, and you got 7, 1. So plot those 3 points and use a ruler to draw a nice triangle. Okay. Now you have to find the image of the triangle ABC after the glide reflection. So first you do the translation. Translation means you slide. So over here it says X become X minus 12. So what you do is when it's minus 12 means you go 12 in the negative direction, in the negative X direction. So from here, if it's very easy if you do on the graph paper. So you just go negative 12, right? So from it you go negative 12. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so from here you go 12, you end up right over here. For the B, again, you just go 12, you end up right over here. The C, you just go over 12, end up right over here. So that's your translation, means you slide. So that's your A prime, B prime, C prime. Okay. Then next you're going to reflect over the x-axis. So here's your x-axis, so you're going to reflect over. So when you reflect over, right, so A, notice is 2 units above, right, 2 squares above. So when you reflect over, so this is 2, so they become 2, right, they have to be same distance. Over here, the B is 3 squares. So when you reflect over, it will be 3 below, okay? And C, that's 1 square, so over 1 square, okay? So it's very easy if you do on the graph paper. Now, what happens if you don't have, what happens if it's not on the graph paper? What happens if they just give you, the number and you have to work out algebraically? Okay, so what you need to do, you have to remember, you have to go back to page 590. These are all the rules for the reflections. Okay, so if you talk about reflection over the x-axis, so when you reflect over the axis, okay, so AB becomes the B becomes the negative, right? See, the AB become A negative B. So the y coordinate become opposite. So if you look over here, see the y coordinate become opposite. Over here, see the y coordinate become opposite. The x stay the same. X stay the same, but y become opposite. See, the x stay the same, y become opposite. So that's what this is. Okay, reflection over x-axis. The a stay the same, or the x stay the same. The y become opposite. Okay. Okay. Now let's go to page 609. Composition. When 2 or more translations are combined to form a single transformation, the result is called a composition of transformation. So again, when you're doing more than one transformation, it becomes composition. Composition is more than one. Okay. A glide reflection is an example of composition of transformations. In this lesson, a composition of transformations uses isometry. Isometry means the object will stay the same size and same shape. So when you slide, the object stays the same size, same shape. Right? It doesn't change shape or change size when you slide. Same thing with when you reflect. When you flip things over, the object stays the same size and same shape. Okay. Okay. Now, it says in in this lesson, a composition of transformations uses isometry. Remember, iso means same, and metry means measurement. So the object will stay the same measurement, means they stay the same. Okay. So the final image is a congruent to the pre-image. Okay. So again, the pre-image means original. So the image is congruent to the original. This suggests the composition theorem. So theorem 9.4, composition theorem. The composition of two or more isometry is an isometry. Okay, so again, when you're doing the isometry, normally what you do with it, it will still stay isometry. Okay, now let's go to example 2. Okay, so find the image of a composition. Okay, the endpoint of RS, so here's your RS. So point R is 1, -3, so go 1, -3. S is 2, -6. Okay, so 2, -6. So over here. So you can plot that first. It says graph the image of RS after the composition. First, reflect in the y-axis, okay, and then rotate 90 degrees about the origin. So let's go and do a reflection. So reflection in the y-axis. So here's your y-axis. So you reflect over that. So when you reflect over, you just count the square. So this is one square from it, right? So when you reflect over, they'll have to have the same amount. So 1 square over, so it'd be right over here. This is 2 squares from the axis. So when you flip over, it will be 2 squares. Okay. Now if you do it by algebra, okay, notice when you reflect over the y-axis, the reflection of the y-axis, what happened? So the x coordinate become opposite, y coordinate stay the same. Okay, see that? So this become opposite, this stay the same. Okay, so if you can see that, so the y coordinate stay the same, but the x become opposite. See, the x become opposite, the y stay the same. Okay, so that's the rule when you reflect over the y-axis. Okay, so that's your r prime s prime. So that's you do the reflection. Then after that, you're going to rotate 90 degrees about the origin. Okay, so again, let's make things a lot easier. Okay, so when you're doing a rotation, remember this is talking about rotation about origin. Okay, if it's not about the origin, then you cannot use these. Okay. Okay. So when you rotate, right? Okay, now this is rotate 90 degrees. Okay, so what happened? Rotate 90 degrees is right over here. So when you rotate 90 degrees, okay, what happened to the numbers? Well, first you switch the x and the y, right? AB become BA, right? And you have to make the first number opposite. So first you switch the number, and then after that you make the first number opposite. So over here, if you switch the numbers, become -3, -1, and then you make the first number opposite, so become +3, -1. Okay, and the same thing over here. First you switch the number, right? Switch the position. So when you switch, it becomes -6, -2, and you have to make the first number opposite, right? So -6, -2 becomes 6, -2. Okay, again, rotation, okay, 90 degrees rotation. First you switch the number, right? AB becomes BA, and you have to make the first number opposite. B becomes -B. Okay, so again, switch, make it opposite. Okay. So again, you can do it either way. Okay, so if you have graph paper, you can just graph, reflect, rotate, then you can write down the number. Okay, if you do it algebra, okay, again you can just go through all these, right? You reflect, do the numbers, and then do like what I do over here. So get the coordinates, and you rotate, get the coordinates. Okay. Okay, now let's go to theorem 9.5. Okay, there are 2 reflections. Okay, so it says 2 reflections. Composition of 2 reflections results in either a translation or rotation, as described in theorem 9.5 and 9.6. So when you do the 2 reflections in a row, okay, you're going to end up become a translation or rotation. Depends on the 2 lines. So if 2 lines are parallel, then it's going to become a translation. Okay, so theorem 9.5, reflection in parallel lines theorem. If line K and M, so line K and M, so these 2 lines are parallel, okay, then a reflection in the K followed by reflection in the M is same as a translation. So again, if you reflect over and reflect over the two parallel lines, the result will be same as you sliding it over. Okay. Also, another things to remember is, okay, these are important facts. If P double prime is an image of P, so if P double prime is an image of P, then P double prime, so P double prime, this right over here, is perpendicular to K and is perpendicular to M. Okay? So again, when you reflect over two parallel lines, then the line P and P double prime is going to be perpendicular to the K and the M. Okay? Also, this distance over here, okay, so from P to P prime, this distance is going to be twice the distance between the parallel lines. So if they say the distance equal to like 2, okay, between the parallel lines, then this distance would be equal to 4. So you double that. So again, the distance between the original and the image would be equal to twice the distance between the parallel lines. Again, use your common sense, right? Because you reflect, that's what, 2, right? That's why you times it by the distance by 2. Okay? Okay, now, let's go over example, okay, and after we can talk about what happens if lines are not parallel. Okay, so over here, example 2, it says in a diagram, so whenever you're doing the problem, it's good idea to draw the picture and label the numbers on the picture so you can visualize. Okay, don't do things in your head because it's very easy to make careless mistake if you don't visualize. So it says in the diagram, a reflection in line K maps GH, so GH to G prime H prime. So this one you reflect over the blue, you reflect over this line, it becomes the red line. And then after that, a reflection in line M, okay, maps G prime H prime to G double prime H double prime. So right now you reflect one more time, and it becomes green. Okay, and here's the HB equal to 9. So this is 9, and D double prime is 4. So this is a 4 right over here. Okay. So what is the length of G double prime? So what's this distance over here? So you have to do a little bit of thinking, right? So if this is 9, when you reflect over, this will also 9, right? Okay? Right, because it has to be same distance, right, when you reflect over. Now this one you have to go backward. If this is 4, and this came from here, so this would be a 4. Okay? Now when you reflect over two parallel lines, it's same as sliding over. Okay, so when you slide over, what would be the amount? Well, 9 plus 9 plus 4 plus 4, this will give you 26. So from here to here would be 26. So G double prime will equal to 26 because this is same amount, right? So the point H slide over 26, then G will have to slide over the same amount. Okay, so there's 26. Okay. Now over here, it says name any segment congruent to each segment HG. Okay. Well, the congruent segment would be this one. So the G prime H prime would be congruent to that. G double prime H double prime will be congruent to that. Okay. And HB, let's see HB. Okay. So what would be congruent to HB? The answer would be H prime B. Okay. And what is congruent to GA? GA. Okay. Answer would be G prime A. Okay. And B, does AC equal to BD? Explain. So AC, does AC equal to BD? The answer is yes, because these are parallel line, right? And parallel line, and this is right angle, so all this is actually a rectangle. Okay, when you have parallel, when you slide over, it forms, so ABDC is actually a rectangle. So opposite sides of a rectangle would be congruent. Okay. Okay, so anyway, the solutions are over here. Okay, so I just explained that, right? Okay, now let's go to theorem 9.6, reflection in intersecting lines. So we just covered when you reflect over two parallel lines, it becomes same as sliding, okay, or translation. When the two lines are not parallel, okay, when the two lines are not parallel, it becomes a rotation, okay. So this one here, if you reflect, is same as rotation, okay? And just like the distance, right? The distance, the resulting distance would be twice the distance of the between the two parallel lines, right? Because when you reflect, that's twice, right? So that's why this is twice the distance of the distance between parallel lines. So it's the same concept. So when you reflect, the angle of rotation would be twice amount of the angle between the two intersecting lines, okay? So over here, theorem 9.6, reflection in intersecting lines theorem. If line K and M intersect at a point, that means they are not parallel. Then a reflection in K followed by a reflection in M is same as rotation about point P. Okay, so this is the point of intersection. The angle of rotation is 2 times or 2x, where x is a measure of the acute or right angle formed by K and M. Okay, so again, when you reflect over 2 lines that are not parallel, then amount of rotation is twice this angle over here. Just like when the 2 lines are parallel, it's same as sliding, and the distance would be twice of the distance. So when this would be twice the angle over here of the rotation. Okay. Now let's go to page 611, example 4, use theorem 9.6. It says in the diagram the figure is reflected in K. Okay, so here's a 9K. So the blue fish you reflect over become the red fish. It says the image is reflected in line M. So the red fish you reflect over in M and become the green. Okay. It says describe the angle of transformation that maps F to F double prime. Well, if this is 70, then this is same as rotation of 140 degrees. Okay. Because remember it's double, right? When you reflect, you do it twice, so it's double. Okay, so therefore the theorem 9.6, a single transformation that maps F to F double prime is 140 degrees rotation about point P. Okay, so again, when you reflect over 2 non-parallel lines, it's same as rotation, and the amount of rotation is double because you reflect. You do two of them, right? So the angle of rotation will be double, so it'll be 140.